All right, welcome back to the compiler design course. Before we get started in this, I want to run something by everyone. When I started this, obviously it's a compiler course. It's really about the compiler and different ways of using compiler technology. But we're also building up a bit of a game. And this kind of game is, at least today, we would want to have it networked and multiplayer. So before I delve into that, what I want to do is get some feedback from everyone. So if you're interested in me making this into a networked multiplayer game, please leave a comment. We don't no longer have like a survey system in YouTube. They've taken that away, or I would have put up a survey. But yeah, just leave a comment on this video if you're interested in doing multiplayer and doing networking and multi-threading and all that, and combining it with this. And if you are, then if enough people are interested, then I'll plan out that part of the course and maybe make it I don't know, perhaps we'll move it into a different playlist or something. I don't know. Let me know what you think. Give me your thoughts on it, and we'll take a look at whether we can do that or not. So let's go ahead and bring up Visual Studio Code here and start taking a look at the compiler design. I've got to open a different folder here. Compiler design, okay. And I need to switch a little mode on here so that I can also bring up a new window here so I can take a look at my notes on the other screen. Okay, there we go. All set. Let compute a float. What happened to this? Did something change here? Huh. Interesting. Oh, that's right. I have my other code in another project. Well, we won't worry about that at the moment. Let's put this A times B up here. This is the initial statement that we want to parse. So where are we? Let's get back on track here. Okay, here's our parser, and we've gone up through getting parameters. These are the parameters that'll be in a let statement, which I believe is up here. Yeah, this is this parameter list part of this. We still have to do the body, the statement lists, L values and R values, and so forth. So we'll walk through these step by step. The next part of this to do is an expression. We've got two types of expressions. Well, we've got several. We've got R values and function calls and unary expressions, binary expressions, and this if expression here to work out. So let's begin with the binary expressions because they're very straightforward. So let's go over here to our AST. I'm going to move it over here where I can be sure to find it. And we've gotten down through parameters. So we're going to have a number of kinds of expressions that behave in a little bit different way. So we're going to start by creating a base class for expressions that'll be based on node. And there's also, at some point, some refactoring I'm going to want to do here of our base node. There's some additional stuff. And while we're at it, I'm going to change this from visit to accept. And change that in all of these before we get too far along, because that's really the norm or the standard. And I see that this public parameter down here does not have this accept method. We need to have that in there because it is abstract. So up here, so this would be an abstract type. We wouldn't be able to create one. Let's just double check that things compile. And they do seem to compile. Where's our test? Did we set this up? Let me get back on track here. Game. We need an input file. Test.fng. Okay. A, B, float. So it's finding things. So it is running and it is working. Okay, let's look at expressions now. Expressions are things that have a result value, but they aren't necessarily what we call an L value or a storage location. They could be, or a storage location could be part of an expression, but an expression itself is going to be a type of R value, and we'll kind of get into that. But for the moment, what I'm going to do is create a base class called expression, and it's going to publicly derive from fng node, like that. We'll do protected. Nope. Oh, yeah. No, actually, an expression itself is an abstract thing. So we'll just do this. It's just a base class to be able to hang expressions on. And we'll be able to add some behavior into expressions at some point in the future, and that's why I create that kind of breakpoint. So what we want next is a binary expression, and it's going to publicly derive from expression. Oops. Now let me check one thing here on our node. Is there anything? No, there's no constructor. There's really nothing to do, so that we don't have to bother with anything on this, and we don't have to pass anything through. So we'll set up a protected section here. And what do we want? Well, a binary expression has potentially two expressions. It has an expression, an operator, and another expression. That expression could be a numeric value, a string, or it could be another complex expression or a function call or anything else. We have to take all those things into account. So what we need here is an expression pointer. So this is our base class expression. It's not just any old node. It's got to be derived from expression. And we'll call this the left side of the operator. And we'll have an expression pointer called the right side of the operator. Okay? And then, of course, we have to have an operator. And I believe... let me take a look at the parser here. So we've got these, but these are part of the parser. These tokens are part of the parser, and I don't want to use those, not directly. But these are our binary operators right here that we're going to deal with. And then we've got unary operators and function calls and regular expressions. So I'm going to copy those back here to the AST, and I'm going to go up here and create our operators. I just copied them to make sure I get all of them. So we'll go enum class operators. I'm going to paste these in and just take all of this out. And then we got to take this garbage out. Comma. 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 Edit these real quick. So we will have our own operator identities in here that we can use. Oops. Okay. So now we've got a set of, oh, I called it operators. We'll call these binary operators. We'll have another one for, well, actually, I'm just going to call them operators. We'll add the other ones in. Do we need to distinguish them? We'll have a different class to distinguish them. So what other kinds of operators do we have? Minus and plus are taken care of. We need a not operator. And we need an increment and decrement operator. And whether they're pre or post, we'll handle that at the class level. So what we really need is not, increment, and decrement. So let's add those in. So we'll have not, and we'll have increment, and we'll have decrement. All right, and whether they're post or pre decrements, we'll deal with that elsewhere. So operators, we have underscore operator. All right, public. So to build one of these, binary expression, we need a expression pointer left. We could be we could go operators op and expression pointer right, and that way it follows and looks just like our expression, right? So the left, the operator, and the right follows it, keeps it neat and easy to read because it follows the same pattern that we'll see them in. So we'll go underscore left, left, underscore right, right, oops, let's go underscore op, operator, op. And do I want to spell that all the way out, operator? Yeah, I'll spell it out. And we don't need this comma, put that there. Okay, there's our constructor. So now we want to do a expression pointer get left, return underscore left, expression pointer get right, turn underscore right, and operators get operator, turn underscore operator. Okay. And then we need to do these two things here. So we'll go ahead and do something to print it out neatly. And we did this toString up here. For the type, we should go operator toString as well. So we should go static standard string operator to string operators op. We'll grab all these, do a little quick editing here. We'll go switch op, paste these in. I am going to go, I'll do one. We'll go case operators colon plus copy that. Well, down here. Bring this up on the screen so I can see them all. Paste those in and get rid of the commas. Put a colon in place. Yeah, programming like this can be a little tedious, especially building these kinds of functions. They're very repetitive, but they're kind of necessary if we want to print things out nicely. So then what we can do is just tab out. Here are ways, and we can go return standard string plus. We can copy this. And there we go. Now we can go to here. Oops. Start here, here, paste all those in. And then we have minus times divide mod equal not equal less than greater than less than or equal greater than or equal not, and then plus plus and minus minus. There we go. Let's switch TCH. There we go. Let's tap that in. That looks nice. Make sure this all builds. Something doesn't like it. Underscore indent. What's the underscore in? Oh, ident. Okay, so we don't need this. We want to print this out differently. So what we're going to do here is we're going to go underscore left pointer out OS, and it returns a standard stream. So then we can go here and we can go op to string op and underscore operator, and then that returns a string. No, that doesn't return an O stream. So then we can go underscore right pointer out OS. There we go. Return OS. Should be okay now. All right, but we're not using it yet. So now we've got our binary operators, and they're all expressions. So what do we need to do? We need to go over here, parser, and we need to decide what type expression's going to be. And we just created expression, so it's going to be an expression pointer. Expression. And we come down here, percent type expression, expression. Oh, no print, no semicolon there. So now we know what type expression is. We don't have an R value yet. That's okay. What we can do here is go that $$ equals new. This is a binary expression. We need the expression on the left, which is an expression, so that's going to be $1. We need an operator. So in this case, we need operators, : plus, because we need the one from our AST, not the one that's in there. And then we need $3. And let's make sure that compiles and that I didn't do anything dumb. Compiled. We got a few warnings. We'll go back and clean those up. A lot of these warnings are just because we're not finished with our compiler. Let me check the time real quick. Oh, we're at 21 minutes. We'll go a few more minutes here, and I'll quickly do these, and all we got to do is change the operator for each of these binary expressions. What happened here? I must hit Control-C by accident. Copied the whole line. There we go. Tab in. Oops. And so this is going to be minus times, oops, colon in there, divide, mod, EQ, not EQ, less than, greater than, LT underscore EQ. IntelliSense is finally working. GT underscore EQ. And let's see if this builds. And run it. Okay, now what can we do here? We're really not pulling any expressions out of that yet, I don't believe, because it's, I don't know, where are we printing those out anyway? Is it in main? I forget. I work on a lot of different projects, so I forget things sometimes. What are we doing here? We're getting our input, the function parser, so we're just running the function parser. Are we printing anything out in the Lexer? No, I don't think so. What are we printing? Oh, there it is. So we've got a debug $2 here. We probably don't need those anymore. They're just so I think it shouldn't print out. Oh, we got some more. Let's get rid of this and this. Let's make. I think it shouldn't print out anything. Okay, it didn't. All right. So how are we going to handle unary expressions? We got a couple of different types. We have unary expressions where there's something prior to it. And even though plus an expression doesn't really do anything to it, I put it in here because it is a valid mathematical thing to put a plus in front of an expression. It doesn't change the expression in any way, but it is valid to put it in front. We've got this special case of an if then else, and then we've got pre and post increment and decrement. Okay. So we can do unary expression can be an abstract thing, and then we can have pre and post expressions below that. So let's do that in the AST. So let's create a class we'll call Unary expression. We'll try to do these quickly and get done with this. This is an abstract class. We won't ever use it directly, but it will house the idea of a unary expression, so that we'll have a class called a pre-unary expression. Actually, we can use this class up here. This is going to be of a unary expression, because a unary expression, we can do this. We can go protected. Unary expression only has one expression pointer underscore expression, and it has an operator underscore operator. I'll be consistent and do that. We can go public unary expression, expression pointer expr, operators op underscore expr underscore operator op. There we go. So now we can very quickly and easily just go, because this is a unary expression, but it's a pre-unary expression. We can go public we need to have this, but we'll change it to this, and we need this and this, but we don't need this. What we need is unary expression expr op, and then we can paste this and make it a post unary expression. And now we do have to put our printer things in here and our accept. So we'll put this in here. That's for a unary expression. No, this is still going to be abstract. It's a holder for that, but it's still abstract. We don't want those in there. We'll put them in here and in here, and we got to change these a little bit. So here in our pre-unary expression, we don't want to do this. We want to get the operator, and then we want to do underscore expression pointer out and return the OS. And then down here, this is the post one. What we want to do is go underscore expression pointer out OS, and then operator toString operator, we'll do it after, like that. So now we've got pre-unary expression, post-unary expression. We can go back to here. Okay, so minus, we can just start by grabbing this. And we will go, this is going to be a pre-unary expression. And it's going to be just $1 followed by minus in this case. We'll get this one set up. And then we got our pre-unary expression for plus, and our pre-unary expression for not. And we're going to skip if for the moment because it's none of those. And then we've got a pre-unary expression for increment and a pre-unary expression for decrement. And then we have a post unary expression for increment. And we have a post, we'll just do it this way, post unary expression for decrement. And now if we do a make, it should still $1. Oh, this has got to be $2 now, and $2. That's $1 and $1. These have to be $2, 2, 2. This has to be $2. See if I got those right. I got something wrong. $2 increment L value. Increment L. Oh, L value. There's R value. Here's L value is an identifier, and L value needs to be of type expression. So that's easy. We come up here and we just put it right here because an L value is an expression. An R value is also an expression. We'll just go ahead and set it now. Do a make. And it didn't like something. Hopefully you can get through this quickly. We're just down to semicolons. Okay. When you get down to semicolon errors, you're doing pretty good. They're pretty easy to find. Pre-unary expression. X, did I spell it wrong? What doesn't it like? Oh. Yeah, well, this is wrong. Didn't do that. Let's try that now. Another error. Find this quick. Error, colon, and nested type name specified, colon, colon. There we go. Read your errors closely. Make sure you understand them. It works. It runs. Doesn't do anything yet, but we're filling it in a little bit at a time. But that's going to be it for this video. Thanks for watching. I hope you enjoyed it. I hope you're getting something out of it. Basically, I'll go over real quickly what we did and what we accomplished. You know, we created binary expression node for our tree. Explaining what it is. It's, you know, an expression, two expressions and an operator, and we'll be able to use this to generate code to create that expression. We've got unary expressions, both pre and post unary expressions built, and we've got it built into our our parser so that it can do that. In the next video, we'll hit the if then else expression, and I'll explain why this is an expression and not a statement, as you will find in other kinds of languages, and why we always have an if, a then, and an else in here. And we can come up with some syntactic sugar for that as well. We'll set up function calls, and we can do this one real quick and easy here because this one's just $$ equals $2. I'll just make sure that that compiles. Yep. it compiles. So yeah, so all we got left to do in this part here is the if expression and the function call, and well, yeah, and a general R value, which is again going to be just $$, equals $1. I just can't stop coding sometimes. I see something and I just want to write the code. So it compiles. There we go. In the next video, we'll take care of the if then else and the function call, and we'll be ready to move on to some higher level things. And this, as we move up this gets more and more general, and we just start moving stuff around and linking stuff up, and it's easier. But we'll get there, and we'll get to the let statement, and then we'll combine it all in. So, all right, that's it for this video. Thanks for watching. I hope you enjoyed it. If you liked this video, hit that like button. If you really liked it, hit the subscribe button. Subscribers really help me. We're growing fast. We got over 300 subscribers now. I'm looking forward to hitting 1,000 subscribers. So if you really want to help me out and help keep these videos coming, hit that subscribe button, and we'll just keep this moving right along. And I do appreciate those subscriptions a great deal. You guys are great. I appreciate your feedback. I appreciate your questions, and I try to answer all the questions I possibly can that come up as best I can. So please give me feedback. And a reminder, if you're interested in doing multi-threaded, networked gaming with this, set it up as a server where multiple players can play in it. Let me know in the comments, and if we get enough interest in that, I will definitely do that. So thanks for watching, and I will see you in the next video.